Since we discovered the first extrasolar planet back in 1992, we have kept at increasing rate discovering new ones. As of 1 May 2019, there are 4,058 confirmed exoplanets in 3,033 star systems, with 658 systems having more than one planet, and these numbers keep growing every year. Among the over 4,000 exoplanets, we have found quite a couple of oddballs, eccentric Jovians in high elliptical orbits, worlds covered entirely in water, evaporating gas giants, and Earths the size of Neptune. But by far, one of the most bizarre planets we have found out there has to be 55 Cancri e, a planet seemingly containing a massive diamond. But before we get to any of that, we will need to cover some basic info about this planet. 55 Cancri e was discovered in August 2004, orbiting the solar analog 55 Cancri a, which is itself part of the binary system 55 Cancri containing a yellow and a red dwarf. The 55 Cancri system is 41 light years away from the Earth. 55 Cancri e is the first of 5 planets in the system. The planet is about 2 times the size of the Earth and over 8 times its mass, and is thus classified as a super-Earth. But 55 Cancri e isn't Earth-like at all. It orbits its parent sun very closely at only 2.3 million kilometers, which is 20 times more narrow than Mercury. One orbital rotation only takes 18 hours. At this distance, the planet is being scorched by the star. Its surface temperature is a raging 2700 degrees Kelvin, which is hotter than the surface of some stars and hot enough to melt silver. In February 2016, it was announced that NASA's Hubble Space Telescope had detected hydrogen, helium, and suggestions of hydrogen cyanide in the atmosphere of 55 Cancri e. This was the first time the atmosphere of a super-Earth exoplanet was analyzed successfully. Besides these hellish facts, this isn't at all what makes 55 Cancri e such a remarkable planet. The planet is special because it's highly likely part of a very rare type of unearthly planet called a carbon planet. Carbon planets are a theorized type of rare planet that contain more carbon than oxygen. Carbon is the 4th most abundant element in the universe by mass after hydrogen, helium, and oxygen. After hydrogen and helium, oxygen is normally the most abundant element on planets. Based on our solar system, there is 3 times more oxygen than carbon on average, but this measurement was taken using only the 8 planets of our solar system, the sun of which is thought to be a 3rd generation star. 3rd generation stars are stars that formed from the dust and remnants of stars that formed from the stars that formed straight after the Big Bang. The older our universe gets, the more time stars have to fuse heavier elements like aluminium, silicon, and iron, which make up significant quantities of the Earth's crust. This means that in the earlier universe, carbon was likely much more abundant than it is today. Planets that are older than the Earth are likely to have a much higher carbon to oxygen ratio than younger planets. Stars of the 2nd generation are generally considered to be carbon-enhanced metal-poor stars, or CEMP stars. As the name suggests, they are rich in carbon and poor in metals. Planets around these stars will likely have the same conditions. It is not a stretch that a planet could exist with more carbon than oxygen elsewhere in our universe. Spectral analysis shows carbon to be more abundant near the center of galaxies. Planets that form there will likely have a very more rich abundance of carbon. It is impossible to know for sure where 55 Cancri e was formed, as stars move through the galaxy in often unstable and chaotic orbits. Tracing these backwards over extended time periods, say the star's age, is nearly impossible to do. Though we did determine the star's age to be approximately 7.5 billion years old. At this age, it is likely a 2nd generation star rich in carbon. And it's a fair assumption that a planet around such a star would be of the same age and thus also likely contain a lot of carbon in its lithosphere. The carbon-oxygen ratio is very critical. Lots of Earth's features depend highly on the dominance of oxygen over carbon. Water, ozone, photosynthesis, none of these would be possible without oxygen dominance. With carbon dominance over oxygen, there would be no such concept as clear blue skies. Think more of a yellow haze with black clouds of such. Water would likely also be a rarity, as it's a compound much abundant in oxygen. Instead, you should think of seas made of carbohydrate compounds, such as methane or gasoline, black bits of ooze rich in carbon. Lakes such as these have been confirmed to exist on the Saturnian moon Titan in 2004. Even though there is more oxygen than carbon on Titan, evidence of liquid hydrocarbon lakes in the polar regions was found. On a carbon planet, this phenomenon runs on steroids. With little to no oxygen compounds, water is a rarity. The air will be saturated with carbon compounds. Methane, butane, penthane, benzene, all these compounds that separate when you refine gasoline. It might be raining these carbon compounds here. Just imagine it be raining butane one day and then methane the next. These planets from space would have a yellow-brownish hue. On the surface, that would be another side effect to all the abundance of carbon. Diamonds. On the surface, you could expect to find pure carbon. If pure carbon is compressed, its atomic structure changes and it becomes a diamond. On a carbon planet, you can expect large quantities of diamonds to be found on the surface. Large amount of carbon-rich minerals, such as graphite and diamonds, will be abundant on the surface. You can see where this gets interesting. If 55 Cancri e is confirmed to be a carbon planet, we can be in for an even bigger surprise even still. Its immense proximity to its parent star caused insane tidal forces on the planet. Tidal forces can mess a planet up big time, as is evident from the Jovian moon of Io. Io is only 420,000 kilometers away from its parent Jupiter. The massive gravity of the gas giant and the other Galilean satellites pull on the moon with insane forces, causing tidal heating. The friction makes Io the most geologically active body in the solar system. It is so active that any attempt to map it would be outdated in only a year time. The tidal forces of a star on a planet in orbit 20 times more narrow than Mercury and 146 times its mass is gonna be under serious geological stress. The tidal forces push and pull on the planet. Combined with a raging hot temperature, it's the ideal conditions for the planet to be a giant natural diamond production line. In fact, the conditions on the planet are so ideal for diamond formation that the process has likely gone into overdrive. And since the parent star, and thus likely the planet, are over 7.5 billion years old, over a third of the planet's mass has likely been compressed into one gigantic diamond. 55 Cancri e is essentially one giant diamond in space. For this it earned the nickname the Diamond Planet. This diamond planet sits only 41 light years away from Earth in an orbit around a sun-like star. With a mass of 8 times the Earth, that's a diamond nearly 3 times as massive as our entire planet. This would clock in to 16 septillion kilograms or 80 octillion carats of diamond. This would have a mind-baffling value of $389 million. Do keep in mind, this is my own estimate of its value, and I could be off, but it's still fun to theorize about this though. $389 million is such a huge amount of money. That's enough money for you to buy 320 octillion iPhone X's, or you could buy a few hundred septillion Mona Lisas and pay the US national debt 14.5 quintillion times over. In fact, this amount of money is more than that we have here on Earth, all financial assets combined, multiplied by 1,000 per human on Earth. That's how insanely much the Diamond Planet is worth. But before you jump in your spaceship all excited to get easy rich, keep in mind that taking home this amount of diamonds, so to speak, would instantly make diamond the least rare material on Earth. Diamond values would crash and you would create the biggest economic crash ever known to mankind to occur. Hyperinflation would skyrocket to the largest numbers ever. So we'd be best off admiring it from a safe distance. In 2014, the International Astronomical Union renamed 55 Cancri e to Janssen in honor of the Dutch spectacle maker and telescope pioneer Zacharias Janssen. However, it is still most often referred to as the Diamond Planet. Despite all of this, it is still out of our reach. A trip to 55 Cancri by current technology would take a decent several 100,000 years. And even if we were able to get out there and mine diamonds, bringing them home would instantly destabilize our economy, so we better won't try it, for our own sake. Of course, 55 Cancri e is only one oddball among a variety of strange planets we have found out there. If you did enjoy this video and want me to do more exoplanet related videos, tell me in the comments or join my Discord server. Its link will be displayed at the end of this video in a few moments. That was all I can currently tell you about the Diamond Planet. I hope this video was enjoyable and educational, and I hope to see you next time on Yiji Science.